С удовольствием приглашаю на эту сцену Гвидо TRONCA, специалиста из Италии с большим опытом изучающего контроля, сотрудника швейцарской фирмы Proceq, которому доклад будет на английском языке, а помогать ему в переводе для вас будет директор фирмы Proceq Rus Левин Вячеслав Юрьевич.
Okay.
Welcome.
Which is
One small, please, applause for our guest.
In Russian that I know.
Thank you.
And thanks, Slava, for providing the translation that I'll be giving. I'm sorry, I'll be speaking in English, but okay. Okay. Now, before joining Proceq, I was actually in on-site testing. I've been doing that for about the past 15 years, mainly focusing on site inspection and always dealing with non-destructive testing. Now, there's always been a sort of a clash between direct and non-destructive testing, and fans and supporters of one and the other. And what I learned on my way is that, well, for any kind of information we need to extract from a structure, there's a direct way of doing it and indirect way of doing it. And there are peculiarities of the one and the other. Okay, now from the classical method, the good things about direct testing, by definition direct testing is done by performing, by consuming a small portion, small or a large portion of the structure to be extracted. Version. But the very good thing is that always provides a quantitative certain information about it. I need to know how big a rebar is. I just open, I drill, and I measure it. That is for sure a true information. On the other hand, I only have information on that specific spot where I visualize or when I drill the core to extract.
Я надеюсь, вы знаете.
Do they? I don't know.
Можно без перевода.
В общем, если кому-то надо перевод, я могу переводить частично. Надо Александра Юрьевича пригласить, он это очень хорошо умеет. В прошлый раз демонстрировал.
On the other hand, by definition, non-destructive method relies on some other mechanical or physical parameter related to the ones that we want to measure, and it provides, it doesn't provide always a certain quantitative information, rather a comparison, but the good thing is that it's fast and it can be extended to huge areas. Now, what I'll be briefly speaking about today is what we can do with the concrete strength. So we have a classical direct way of doing, crushing things, either tubes or cores, and non-direct methods. I can measure a rebound, I can measure speed, I can measure a penetration depth, I can measure a number of things. Do you think we need to go with translation for every slide?
Скажите, насколько обязательно делать перевод? Мы его планировали, но тут Гвидо со своей скоростью нам не дает ставить слова по-русски. Если вы не будете сильно возражать, если мы послушаем английскую речь, да,
практикуем.
Значит, вопросы, если будет вопрос еще раз на русском, вот, мы постараемся. Но давайте на английском. Нет возражений?
Я speak English.
Yeah, we are. Let's go.
Okay, very briefly, everybody knows about coring, just speaking about strength. Coring, what do we measure? We measure a force applied onto a core or onto a cube. It for sure provides a certain information, and as a matter of fact, in most countries is mandatory, so it's not an option. What's the point? The disadvantages, it's destructive, and takes time, and more than that, it provides information on that specific sample of concrete that is crushed. The first and classical NDT method for strength that everybody knows, rebound hammer. Rebound hammer is just we measure either a rebound distance or a rebound speed, more recently, quick, totally non-invasive, very easy to do. I mean, even in small spaces, confined spaces, I can still go there with a hammer and provide some application. The main limitation is that typically surface testing. We're speaking with around 5 to 7 millimeters of concrete. We don't know anything that's below that. So we assume that it's representative, but it's still an assumption. Secondly, in terms of time, and probably among the main in terms of number of application, we measure ultrasound. Do we measure a strength? No, we don't. We measure a time. And then we correlate that time with the speed and the characteristic of the material. Very fast, totally non-invasive. It is the only non-destructive testing which reflects the bulk properties of the element. And it is the one that, for a specific kind of concrete, best correlates with the actual strength. Now, limitation. It's sensible to the concrete which is being investigated. Ultrasound will be different not only from a building here in Russia and one my place in Italy, but if you take two buildings here in St. Petersburg, they will behave differently because they will have different aggregate size, whatever. It requires rebar detection first. So generally it requires a more qualified user to do that. And in order to be applied at its best, it requires direct transmission. So if I don't have access to both sides, that's not so easy applicable. Now, we mentioned, there are others. There's the Pullout Testing where we measure strength, there's the Windsor probe where we measure a depth of penetration, whatever. I'll be always measuring some physical parameter. Now, what do we do with our data? That is the main concern of the user. So, basically, there are 4 possible approaches. 1, I do not correlate whatsoever with mechanical strength. I just provide a qualitative information. Decent, terrible, excellent, that is something that I can do. But hey, you might want to do something more. I can just grab my hammer and read the calibration curve, or use whatever SONREB calculation taken from literature. That's another option. Or I can build my own correlation curve. So I will have some sample crushed, and I will have the corresponding NDT parameters available. I will build my calibration curve. From a practical point of view, there is a further way of doing, which we will see, which is taking an actual correlation curve, which requires lots of samples, and by means of few calibration spots, we can modify that curve and move it in order to make that specific to the structure that is being investigated. So, very quick overview about the first approach, total qualitative approach. This was taken as an example from literature related to UPV ultrasound speed. So, according to a general number of authors, we can state that below 2500 it's pitiful, and above 4000 1000 is very good. Hey, it's already something. It is always to be preferred a true qualitative information rather than a wrong quantitative information. So this is the criteria. Or, next step, I reported the old style label that was on the instruments. Those are other curves that are provided by manufacturer. But the real naked truth is that it's insufficient for the accuracies that it is required. Just reading the value is a wrong way of doing the testing. I can do literature search and I can find a number of authors. Here I just took 3 as a pure examples. These are examples of SONREB curves, sonical and rebound SONREB. So a number of authors tried to correlate that with strength. Now, the simple fact that if you Google SONREB in an hour, you will find probably 20 different curves. This by itself proves that there is no one correlation between non-destructive parameters and strength. Again, not sufficient for structural purposes, assessment purposes. Now, let's start being professional. If I am being paid by a customer to assess the strength, I want to give a certain value with its associated uncertainty. So, hey, let's go back to school for a little while, and if I measure this parameter, which can be a rebound, a speed, a penetration depth, I have to build to find this function which will provide my strength. From a practical point of view, this is an example where 8-9 locations we did measure ultrasounds first. On the same spots we drilled cores, crushed them, got the results. You stick together all the things in a graph, and you can make whatever curve you want, basically with least square analysis. In this specific case, it was an exponential curve. Exponential and power curves are mainly accepted. Now, what do I do with this curve, though? The idea, the procedure, is I start from a set of spots, pillars, beams, locations, whatever, where I have both the non-destructive and the direct testing. I go stick that into my PC, into whatever software, I'll mention a few scripts available, and I build a curve. Now, with the curve given, I can calculate by mean only of a speed, in this case, could be a rebound, could be extraction force, whatever. I can have a certain strength calculated, so I only pay or invest my time for drilling 8 cores, and I can recalculate about whatever, in this case about 40 locations. This is what is normally done with one variable, but hey, we can play a little further and start going SONREB. SONREB means sonic, speed, and rebound. In this case, we don't have a curve anymore, but we have a wave, a sort of a surface. But hey, again, it has an equation. My goal is to calculate these A, B, C parameters by mean of the available data set. Again, there are software for doing that. There is software, there are scripts, and those are fully available. same approach, I do have a set of measurement where both speed and rebound, I apologize, didn't have time to translate, this is even in Italian, but trust me, piazzola is location. Speed, rebound, and measured strength on cores. Then I build my curve, calculate the ABC factors, and with 5 cores, I can go back to a full set of strength, which means moving from measured to calculated strength. Now, just to say that, hey, we're not into a statistic or math seminar. We're into civil engineers. We don't have time to develop software. Okay, for example, Proceq developed a script which is available on our site, which you just stick in the values that you measured on site, you wait for your lab to deliver the crashing test on the cores, and then you have your constant. So it's something fully doable by an engineer. We don't require a software programmer to do that. Now, there are many cases, this works just fine. You can do a number of publications with that. But if your goal is not doing articles, but hey, making a living out of NDT like I've been doing, there are a number of scenarios where you don't have enough points. You cannot play with statistics if you don't have enough numbers. If my customer doesn't have the money to pay me for 15 cores, say, hey, no man, please, you may only have 3. A number of times you are only allowed to drill 1 core. Hey, that's not easy, that's not immediate to play statistic with that. Hence, we can have this further option, which is basically, this is a normal Excel sheet, it's not even a macro. Basically, I start from the measured speed and rebound number, and I take whatever curve I like, or a number, okay, and I calculate, in the first step, I do calculate this strength according to this equation, strength according to this equation. Then, for every spot, 1, 2, 3, 4, where I have the direct testing available, I just simply perform this calculated, this measured, divided, calculated. Measured, divided, calculated. And I get, in those spots, I get a coefficient, ideally 1, but never 1. So I just plainly average all of them, and I remultiply the first column by the average which is called coefficient of influence. And then I have the full, under graphical terms, I am moving the curve. So this is the literature curve. This is the modified curve. Once I do that, I can go back and check the sum of squared errors, which is basically the difference between real and calculated, and the curve that has the lowest squared error is the one that I will pick from that specific investigation, ready to throw it away for another investigation. But for the structure under investigation, it is the best possible curve. Again, something easily available to download on Proceq site, or hey, it's just a script and nothing mysterious behind. So, just to sum up the testing procedure, the testing protocol, basically, first you go on site and you do measure. Non-destructively. Then you do course, and then you calculate. It seems obvious, but unfortunately it is not. Hence, first thing, I have a building, so let's check representative spots, which could mean a number of pillars for every level, a number of beams, a number of different elements. So I'm leaving my coring machine at home so far. I just want an overview of the non-destructive parameters. In this case, rebound values and speed of sound. Immediately I can have a qualitative information. Hey, that's excellent. Hey, there's something wrong here. So I can already provide answers. All the pillars on the ground floor are better than the ones at the 5th floor. Or this is the worst and this is the best. This is the moment where I am able to assess, hey, let's drill 5 cores, 2 cores, 3 cores, the worst, the best, and something in between. A number of times I was on site and the customer asked, okay, you do SONREB there, and there, and please drill 3 cores, 1, 2, 3. Very simply, why? How can you decide where to perform direct testing without knowing anything about the structure? Well, good reason is that, hey, that core there, it won't bother anyone. No, they're not there because there are the offices there. Well, it's an idea, but it's better to have a strong reason to have representative spots. Then you go on the spots and check, and you drill, and you crush, and then you can move, just as stated before, to from measured to calculated. Which means, when here everything was thought when testing an existing structure, an old structure I don't know anything about, so I go on site and measure non-destructively, then I drill cores, then I perform calculation. Same thing as concept on a new structure that is being built. Hey, since I have already these cubes, and I do have them because the law asked me to do them, why not measure ultrasound and rebounds on the same samples? So in this case, I can already calculate the best curve for that structure, and when I go on site as a supervisor, I can have my own curve and go on site and provide a quantitative information about what is being done on the construction site. So at the very conclusion, just to summarize what, well, sort of my learnings, why make 10 cores when with 3 cores I can provide the same information? First, are those cores representative of the best, the worst, and the average behavior? This is something that only NDT can provide. And of course, I can extend the information collected by 5 cores to 50 or 500 locations at the same cost. This is just a general overview of, well, my modest experience. And that's it.
Thank you, Guido. Do you have any questions for our speaker? понял. Есть вопросы?
Добрый день. Вертынский, город Балакова, BT, филиал НИЯУ МИФИ. Вот. Вопрос такой, ну, насколько я понял, как бы, по презентации, насколько ваши методы, допустим, да, и вот неразрушающий контроль применимы к бетонам с повышенной металлизацией? Поясню немножко. Недавно обследовали бассейн выгрузки-перегрузки, то есть там в качестве заполнителя используется окатыш, металлический окатыш. Вот. Насколько это может, допустим, помешать, либо это никак не влияет. Потому что мы делали вот, ну, практически то, что предлагают, то есть делали по проекту бетон, да, отдельно, соответственно, ультразвуком его проверяли и потом переходили на натурную конструкцию. Получились не очень как бы хорошие результаты, и нам не очень понравилось. Вот. Хотелось бы узнать, может мы где-то ошиблись, а может действительно это никак не применимо.
Я не думаю, что это вопрос по адресу, потому что доклад был в целом про методику, но я постараюсь...
Ну, просто, может, да, может, как бы пояснят.
Do you have some experience of testing concrete with a specific aggregate, like pieces of metal inside, metal inclusions? He asked about it, very specific concrete with metal inclusions, like a coarse aggregate.
I did some with metal fiber reinforced concrete.
Он говорит, что имел опыт с работой с фибробетоном, с металлическими включениями. Но у вас был не фибробетон уже спрашивали сейчас. Вопрос был...
То же самое.
То же самое. Okay, and what...
Well, the only difference is that I just put away my ultrasound and I maybe take out my pullout testing. But I treat the pullout and the rebound results just like I would do with speed and rebound.
Он говорит, что в данном случае неприменимо, ну как бы нет смысла применять ультразвуковой метод, потому что волна пойдет через металл, да, но в то же время можно применять калибровку метода отрыва, который применяется в Европе, да, собственно, или метода ударного упругого отскока. Вот, и делать ту же самую калибровку, ну и Гвидо говорит, что опыт был нормальный, положительный на вот таком вот материале. Коллеги, еще есть вопросы к докладчику? Я позволю себе просто добавить от себя, что основная часть доклада, ну, для тех, кто не смог понять по-английски нормально, да, была о том, что, ну, я вот, по крайней мере, что понял, скажу так, в Европе тоже хорошие специалисты понимают, что нельзя прийти с прибором, ткнуть молотком или ультразвуком, определить прочность, но нужно использовать градуировочные зависимости. Лучше всего, если они будут построены конкретно на этом объекте. А основная часть доклада была о том, что Гвидо, я так понимаю, что разработка Гвидо, да, программа макрос, Proceq, в частности, для своих клиентов разработал некую программу, которая позволяет, ну, делать собственные кривые с учетом, я не помню, это двойной. В общем, смысл в том, что призывает Гвидо использовать построенные или адаптированные калибровочные кривые для применения. В принципе, у нас на это ГОС есть. С другой стороны, что меня вот радует, что люди из-за рубежа тоже к этому стремятся, а я знаю, что большинство организаций на стране не следует требованиям ГОС, к сожалению. Вот это мое мнение по услышанному. Если, может, какие-то вопросы еще дополнительные. Да, спасибо, пожалуйста.
Меня зовут Виталий, да? Там в графике третий параметр был введен. Там скорость в зависимости от прочности, а потом 3D график был. Вот что там за новый А, Б, С. Отскок, да? Ну, сказали уже, да, отскок.
Okay, basically, when we look for a SONREB equation, it always made sort like this is the general form, where concrete strength, cubic strength in this case, RC, is equal to a parameter multiplied by rebound value IR is
Понятно.
rebound
Guido,
index.
I'm sorry, but I get it. Там график 3 параметров: упругий отскок, скорость и прочность. Вот в чем суть. И IR это rebound number или высота, в общем, параметр отскока числа. Крайний вопрос, то, что мы уже выбились из графика. Сергей.
Guido, have you tried make this curve with pullout test? I mean with 4 parameters.
Actually, I did with pullout, of course, but never with 4 parameters. Basically, because it would require a very high number of calibration points to be mathematically significant. But it perfectly works if you use, for example, the pull-out instead of the rebound. No problem. Tested, it works fine. It works even better than the standard SONREB. Sure.
Thank you.
Спасибо большое уважаемым коллегам.